Okay, so you probably just finished up the introduction to our kind of self-paced familiarization activity. And I imagine that you probably walked away confused with some things or all the things, and that's totally okay. Uh, for almost everybody in this class, it will be the first time you've ever been exposed to R or probably any coding type language before. And so, as I mentioned at the beginning of this week, the goal is not for you to become masters of R. That is a tough thing to do in a week or two that very, very few people could do, if anybody. And so, really, the goal is for you to know, hey, what is R? What's it used for? How is it used in kind of just a general concept? And that'll help you down the road. Maybe you apply for a job and someone goes, hey, are you familiar with R? Most of our work is being done in R these days. And you could go, hey, I've done a little hands-on with R. I'm not great at it, but I think I could learn it on the job now that I know what it's all about. And that's really what kind of the goal of implementing R in the context of this class is for. And so to kind of keep things nice and simple, we are going to be working again with that cars data set. And we're just going to continue on doing that. And so what I have open now, this is R Studio. There's several different flavors of working with R. R Studio kind of gives you some nice little side windows that the basic R does not give you that I find are very helpful for people just getting started. And so whether you installed R Studio on your own or whether you're using kind of my web interface of R Studio, everything's going to look exactly the same. So to get started, this is kind of what happens when you first open it up. We're not going to be working in here, so not working in here, okay? This is not where we're going to be typing anymore in R. What we're going to be doing from now on is actually making scripts and executing individual lines separately. And this will be kind of a little easier way to do things that'll hopefully help you out. So you're going to go to File and hit New File, and you're going to make an R script. Okay, and so now we've got another window. This is basically just a really simple text editor. And in here, we can kind of keep track of what files we've read in, what commands or functions have we executed, what objects have we made. And maybe some of those words sound familiar, but you already forgot from the previous part, and that's okay. We're going to go through everything again. And so let's start with how we actually read in a spreadsheet into R, because you haven't worked with that yet. And so if you look to the bottom right, these are some files that I've already got in this kind of online repository for you. One of them right here is called Week 3. You could click on Week 3 and look what's inside of it, and we've got this spreadsheet for the cars data set. And you can go back to home here. And so right now, R is in its home directory. Everything that R can see is right here. We need to tell R where our file actually is, because most command line type approaches or coding approaches won't look through your entire computer for a single file. You have to kind of give it an idea of what folder it's in. And so the way we can do that is if we're going to try and read in this file, let's say our function that we're going to be using is called read CSV. CSV is basically shorthand for comma separated values. That's like a very basic format for a spreadsheet. Excel uses CSV files quite frequently. And so just like you saw in the intro to R, you're going to have this function read.csv followed by parentheses. Also kind of similar to how we deal with functions in Excel as well, the parentheses. And so typically you were putting like some kind of object in here, right? That you had already given a name to, something like that. Well, we haven't actually read in this cars data set yet. And so it's not an object. And so when we're dealing with telling R about files or things outside of R, we put them in quotes. And it's okay if you forget this. It took me a long time to remember when to use quotes and when not to use quotes. So don't panic if you don't remember that. But what we want to do is within these quotes is tell R where this file is. And so this file is in this week 3 folder that's inside of our home directory. And it's called mtcars.csv. And so what we would do is we would say, hey, from where you currently are at R, sorry, that's kind of a confusing phrase. We're going to say, hey, go into your week 3 folder, and within that folder, we're putting a slash there to say within. Within that folder, we want that mtcars.csv file. Now, if you're using a Mac, remember you hit Command Return, and it will execute your line that you just typed. That is exactly the same as if you typed it in all the way down here. If you were to say read.csv, blah, 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 and hit enter, it would put it all into this R terminal for you. But instead now, we've actually typed it up here in this script, and we can execute it as many times as we want. We could say Command Enter, Command Enter, Command Enter. This is very nice because you can always go back and redo things, or just kind of tweak. Maybe you typed this out and you spelled it wrong. Maybe you spelled cars with a Z. And R was like, oh, nope, we don't know where that file is. And you go back and go, oh, whoops, I mistyped that. Fixed it. We're good to go. Okay, so this is the format, the function for how we read in a spreadsheet file into R. And here you can actually see the file's just being read directly into the actual R console. And that's not really all that useful for us. So what we're going to do is build on what we learned last time. We're going to make a new object called data. Now, recall that we use these little arrows to basically take these functions or numbers or anything that we want that's typically going to be printed to the console and instead save it as a named object. And so we're going to do that right now. Because we wrote this in the script, we don't have to retype everything. We can go ahead and just copy and paste here. And now we can execute this. And now we have an object that holds that entire spreadsheet of those cars data. So now we could just type data and we could execute it, and there we go. We've got all of our car data saved as data. So what can we do with this now? This is quite a big, well, it's not really that big of a data set, but it's hard to kind of look at all at once. Really, one of the first things I tend to do when I read in a data frame or a data file is I use this function called head. What this does is it basically just looks at the very first part of your data file, typically the first 5 lines. So here I am typing head. I haven't put the parentheses in yet. And I want to mention one of the things that I really, really like about RStudio for learning R is that similar to Excel, you get this little drop-down menu of predictive text. What functions does it think you're trying to type? And then it actually gives you just a little brief synopsis of what this thing is actually doing. So here it is, head returns the first or last part of a vector, matrix, table, data frame, or function. And so really head is going to return the first part, tail is going to return the last part. So what we can do is we can say head, data, and go ahead and just execute that. And now we can actually see what our data file kind of looks like. We can see, okay, we've got a bunch of car names on the first column, and then we can look at our variables. We've got miles per gallon, cylinder, displacement, horsepower, etc. And so that kind of gives us kind of a nice sense of what the different variables in this data set are. Okay, so now I want to walk through how we can do some of the similar things, some things that are similar to what we did in the Excel data set. So what are some of the things that we did in Excel? We generated a count of how many observations we had within our data set. You'll notice that I put kind of a pound sign or a hashtag, whatever you want to call it, before I wrote count. Anything that you put after a hashtag or a pound sign, R will ignore. So we could just type whatever we want here and execute it. Nothing's going to happen. It's not going to get mad, anything like that. So whenever you want to make notes to yourself, like a reminder, like maybe I'd put a reminder here and say, shows the first 5 lines of the file. Now I can remember what head does. Or you could, just say step 2. However you want to annotate your script, that's helpful for you. So just kind of keep that in mind. We call those comments. They're kind of comments to the reader or that's actually using the script. Okay, so back to what we were doing. Count. If we want to do something similar to count in Excel, which if you recall was equals count and then parentheses, well, in R, we can use this function called nRow, basically asking how many rows are there in the data set. And so if we nRow the data, right here it says that there are 32 rows. So 32 observations in this data set. Maybe you're wanting to use this for a report down the road. Maybe you even type in your what it actually was there, 32. That way you don't have to rerun it. You can just kind of make notes as you go. Other things we did. We looked at the mean in Excel. And we can look at the mean in R just as easily. The function is mean. Now, this is going to kick back something a little funny. If we look at the mean of the data, notice R gets a little angry. The reason it gets angry is because data is a stand-in for this entire table. And how would you generate a mean for this entire table? That doesn't make sense. Some of our data points are numbers, some are letters. R is understandably quite angry and frustrated about this. This is where R gets to be quite powerful. We can subset data and look at any individual column with just a couple letters. So rather than looking at the mean of data as a whole, let's look at the mean of the horsepower column. So what we do when we want to look at individual columns is we start with the actual object. So I'll type it out again, data. Now we use a $, which is a stand-in for, hey, I want to look at a column within data. And look, RStudio popped up all the columns for us, even if you didn't remember their names. All right, horsepower. Data, the column horsepower. And before I execute this, let's just see what happens when we look at data horsepower by itself. Here are all the values from the horsepower column of data. And so now when we look at perform the mean on the horsepower column of data, we're going to get a mean of 146. So here you could, if you wanted to, 146.7, if that was something that you wanted to keep track of. Standard deviation. Let's say you want to generate the standard deviation of horsepower. Standard deviation is the function, SD, data, $. Maybe we want to look at miles per gallon this time. Maybe we want to look at automatic versus manual. Let's just stick to this and go horsepower. And there we go. Horsepower is 68.56 and some change. So you could, continue doing all this. But in just a few quick lines, we have already generated the same types of data we got in Excel. And you might be thinking, okay, well, that seems more complicated. And you got the same numbers that we got in Excel. But think about this. If you wanted to all of a sudden change gears and go, okay, I'm done with horsepower. I want to look at miles per gallon. It's really as simple as doing this. Boom. Miles per gallon, separated by that $. Boom. We've already gone through and regenerated our miles per gallon mean and standard deviation. Whereas in Excel, you would have had to perhaps resort or copy and paste columns around to kind of re-get your spreadsheet set up the way you wanted. In R, it's very quick and easy to kind of change these things around. So I'm going to go back to horsepower now. Okay. That kind of brings us to where we were at with what Excel could do. You can also kind of take some shortcuts. Let's say you just want to look at a bunch of summary statistics or descriptive statistics for your whole data set. R's actually got a function for that. It's called summary. It's pretty easy to remember. So let's do a summary of the entire data set and execute it. And here we've got all the variables. Miles per gallon, the minimum, first quartile, median, third quartile, max, mean, for all these variables here. So really a nice way to get all these data that would have, think about how long this would take you to generate in Excel. So that's kind of one of the advantages of R. its flexibility and kind of how robust it can be in looking at lots of data rapidly. Okay, so the next thing I want to look at is we looked at sorting in Excel so that we could pull out whether things had a manual or automatic transition. But here we don't actually have the columns to kind of copy and paste from. So how do we do something similar in R? It looks a little complicated at first, but once you get the hang of it, subsetting your data is actually relatively straightforward as well. So let's do what we did in Excel, and we're going to focus on horsepower in manual versus automatic, okay? So same thing we did before. And so how can we look at this? We've got our data horsepower, and so that's going to be all of our horsepower for both manual and automatic. So that's not really what we want. What we can do is anytime we've got one of these little sets of the column horsepower within data, we can actually pull information from the other columns that are associated with it using brackets. And so we've got data that the horsepower column of data, but we only want the manual transmission for this first one, let's say. So what we want is we only want the horsepower that have a data column automatic manual column. The AM column is what's manual versus automatic. That is equal to 0, which is our manual transmission. And so what this is saying is it's going to pull the horsepower column, but only the horsepower column where those rows have a 0 in the automatic transmission column. So this will be our manual data set. And so here you can see now that list has been pruned down substantially. We don't always want to have to type these things in. So typically what I do is after I figure out what piece of little script is getting me the information that I want, I'll go ahead and slap those arrows on there and I'll name it as an object. So let's say manual horsepower, and we'll run it again, and now we've got manual horsepower saved as an object. Notice another nice thing about RStudio is you can actually see all your objects here. There's our data object. You could actually open it up if you wanted. And then here's our manual horsepower object. And so if you had to guess, take 5 seconds and think, how would you get the automatic horsepower? What would you change in this little line right here? Well, you would change the 0 to a 1, because anything that has a 1 in the automatic transmission column has an automatic transmission. So we'll go ahead and execute that. And now we've got, in just 2 brief lines, the same data set that we had to sort and copy paste to get in our Excel spreadsheet. And so I will leave you with just one more quick little thing, or 2 quick little things. The first is that, remember, we can use summary as a real quick way of getting all of our descriptive statistics. So let's just summarize manual horsepower, and let's summarize automatic. And so there it is. Everything we did in Excel, we've done in just these 4 lines here. And finally, the last thing, really briefly, just as kind of a hint of what's coming next week when we start to look at graphing and data visualization, I want to give you a sense of how quick and easy it can be to make really nice figures and graphs using R that typically I think a lot of students struggle with in Excel. So we talked about box plots. Let me show you how to make a box plot real quick. This is something that we don't need to use this week, though. All you're going to do is type box plot. That's the function. You're going to open it up. Let's say we're interested in looking at horsepower versus transmission type. So we would say the column of horsepower. And here we're going to say kind of a stand-in for verse is this tilde sign, the little squiggle that's in the upper left of your keyboard when you hold shift. Data horsepower versus data transmission type. And if we hit enter, there we go. We've got a nice little box plot in one line. So think about what you've done in Bio 1, Bio 2 to kind of generate these types of statistics and figures, and look how quickly it was done right here. So sometimes, even though R can be a little scary, it's worth taking the time to familiarize yourself with it because it can save you a ton of time in the long term. And so that's kind of my little soapbox on this. But again, hopefully this starts to kind of show you kind of how you can use R to do some of the things that we're doing in Excel.